Precalculus 2019 first 9 weeks assessment. 20 problems. We did this week. I'm going to go over all the problems, some using calculator, some not. Number 1, for the function f(x) equals absolute value, not absolute value, quantity x minus 3 squared minus 10, which equation represents its axis of symmetry? Well, the key thing to know about the vertex form is that if you have the form, this is in the form of vertex, which is quantity x minus h squared plus k. And so what you have is the vertex is the coordinate pair h comma k. In this instance, the vertex is h has to be 3 and k has to be -10. And so this 3 is the x value, the axis of symmetry is. So B is our correct answer. Next, 2, for the function y equals x squared minus 4x plus 6, which equation represents the same function in vertex form? We can do this in a number of different ways. We can graph the calculator to check. We can expand all these below to see which one matches the one up above. Or we can do what I'm going to do now, which is complete the square on this guy here. So to complete the square, we can rewrite this as y equals, I'll put x squared minus 4x. And to complete the square, we're going to have to add something here. And then we're going to bring down, we're going to subtract out here what we added inside. And finally, we're going to add 6 to that. And so completing the square for this x squared minus 4x, if we take -4 and divide that by 2, we get -2. And -2 squared is equal to 4. So we're going to say plus 4 inside here, and we have to subtract 4 on the outside. So what we end up with is y equals quantity x minus 2 squared. And then on the outside, we have -4 plus 6, so we're going to get plus 2. So our correct answer for this one will be D. Next, 3, for the function f(x) equals 3x squared minus 12x plus 8, which equation represents the proper placement of coefficients obtained in the equation for axis symmetry? This evolved from the quadratic formula, which is x squared equals -b plus or minus square root of b squared minus 4ac over 2a. And this part of it right here is our axis of symmetry formula. So x is equal to -b over 2a. Well, in this instance, we're going to be equal to -b over 2a. And so we have a is equal to 3, b is equal to -12, c is equal to 8. So we put -12 inside here, and then 3 inside here in the denominator. So that's going to give us answer choice C. Next, how many real zeros are found in the function f(x) equals x squared minus 6x plus 12? We're going to go to the calculator. X squared minus 6x plus 12, and we graph that. So we have this parabola that opens up above the x-axis. Well, to have a real zero, you need to do what? Touch or cross the x-axis. Do we touch or cross the x-axis here in this graph? No, we do not. So we call this 0 real zeros. Okay, number 5. Find the solutions of the equation shown below, and we have this equation here. So we can use for this what we call the zero factor property of algebra to find our solutions. And the zero factor property is just anything times 0 equals 0. So we have x is equal to 0. We bring down this x minus 3 is equal to 0. And finally, we have x plus 5 is equal to 0. And x equals 0, that's one of our zeros. If x is not, 0 is not there, so a cannot be right. Then we solve these other ones for x. If we add 3, we get x is equal to 3. So this is a negative 3. We don't have 3 here. It's going to be this one right here. Next one, if we subtract 5, we have x is equal to negative 5. Okay, that's answer choice C. Next, 6. Find the binomial factors of the following quadratic trinomial expression. Now, we can do many different things here. We can graph. In fact, I'm going to graph for equivalency just to show you it can be done. But we can factor this thing right here. And to factor, using the x method like we showed in class, if you put AC up here and B down here, A times C, well, A is equal to 3, B is equal to 7, C is equal to negative 6. So AC up here is going to be negative 18. B down below here is going to be 7. So what two numbers do you multiply together to equal 7? Or equal negative 18, but add together equals 7. Well, you're going to have a negative times a positive. We know that. That's how we multiply. Which one's going to be 7? 9 and 2, right? 9 plus 9 here, and minus 2 here. Let's figure that out. If we take negative 2 plus 9, we get 7. But if we take negative 2 times 9, we get negative 18. Check. And now we divide by a, and a is 3. And we simplify where we can on the right, so we have equal to 3. So we have this thing here is going to be equal to x plus 3 and x minus 2/3. And using our bottoms up method, that's going to be equal to 20x plus 3. And then we bottoms up that 3, we get 3x minus 2. And that's going to be answer choice D. I want to show you something else. In your calculator, you can check for equivalency quite easily. So we go here, and we put in 3x squared and my plus 7x minus 6 and I'm going to delete out the rest of this. Oops, it's not letting me do it. Let me try to delete here. I should have just deleted the whole function. There we go. So we have that. We'll graph that function. What does that look like? Okay, the correct answer is going to just trace right over this original one. So we could try one that doesn't work. Let's try answer choice C, which is quantity 3x plus 2 times quantity x minus 3. And if it's right, it should graph right on top of it. But it doesn't. It isn't right. So if we put the correct function in here, we're going to have quantity 3x minus 2 and times quantity x plus 3. And you can see this one trace right over the graph. There's the red one trace right over the blue one. If we go to table view, second, and we can see these numbers the same in each instance. Next, 7. Which parent function below one transform the best model of the data in the table below? So for this, the easiest way to do this, I think, is just to go ahead and enter the data in the calculator. And I'm going to do this as quickly as I dare. Edit. And I'm going to sort of use abbreviated forms of numbers. I'm going to put 0.43, 0.16, 0.04. Try it again. Stat edit. 0.043. There we go. Next one's going to be 0.16. Next one's going to be 0.35. 0.59. 0.89. And finally, next column, 1.26. So we have all the x values entered here. Next we go to enter the corresponding y values. We put in 0.82, 1.71, 2.46, 3.05, 3.74, and last one, 4.5. You got to make sure you have the same matchup here on each side. We go to y equals, and I'm going to clear these things out here, and we're going to turn plot 1 on. When we do that in a graph, this is what we see. And we really can't get a clear look at it. One way to get a clear look is to go to zoom 9, which is zoom stat. And we see this kind of thing. What is that? That's going to be it's like a square root type function. And that's going to be answer choice C. Eight, which of the following four graph polynomial functions might have an odd degree? Well, for an odd degree, you need to have limit as x approaches infinity of f of x equal the same thing, infinity. You have to have opposite signs. So in this case, the limit, B is the correct answer. The limit as x approaches infinity of f of x is actually negative infinity, and the limit as x approaches negative infinity of f of x is equal to positive infinity. We got to make sure our limits on each end are different for an odd degree polynomial function. 9, for the function graph below, describe the nature of its degree as even or odd, whether the function is negative or positive. So this is going to be an odd degree function. In fact, it's going to be, it looks like it's going to be y equals negative x to the 1 power, or y equals negative x. That's kind of where it looks like. Maybe not exactly, but pretty close. So you're going to have, and we're going down, so that thing's negative. So we have odd negative is what it is. And the limit as x approaches infinity, we're going down, is going to be negative infinity. So therefore C is going to be our correct answer for 8, for 9. 10, for the graph of the function pictured below, over which approximate interval is it increasing in value? Well, we can take our minimum here at x equals -3 all the way up to where x is equal to 2. So -3 and 2 are the critical values we're looking at. Only possible choice B. Next, which of the following rational functions contains a removable discontinuity. There are many different ways to do this. Probably the way I would like to do this analytically, the best would be to take, you notice all these numerators are the same. So we can take this x squared plus 2x minus 8 and factor that into two linear factors. So if we take, we're going to have x and x, and we have negative 8, so we're going to have a plus and a minus. The plus is bigger than minus, so what two things will multiply together equal negative 8, but add together equal 2? Well, plus 4 minus 2. And if we do not have a cancellation, that would not make it a removable discontinuity. This would be a non-removable discontinuity. It cannot be A. And if you go down here, you have the same numerators in each case. Well, down here for C, you're going to have quantity x plus 4 plus quantity x minus 2 over x minus 2, and we have cancellation here. So that's going to be your removable discontinuity. And when you graph the thing in a calculator, you're not going to see anything. Let's see. We're going to see x squared. Yeah, we'll do x squared. We're going to factor it. X squared plus 2x minus 8 all over, I'm going to do choice A. I'm going to put x minus 4. Okay, so, oops, kind of off. I'm going to go to zoom 6 for zoom standard. Okay, well, we don't really see it here, but it's a evidence of a, make this 20, make this negative 40. I think we're going to see it here. Positive 40. I'll make it positive 50. So there we have, you see our vertical asymptote here. But if we go here and we put in our correct answer, which is C, which is our denominator x minus 2, what are we going to see here? A line. Okay, we will only see the discontinuity in our table view, where we look at 2, control graph, we see 2, we have an error. We don't see it when graph. C is our correct answer. 12, which of the following rational functions exhibits a jump discontinuity? I have some people pick A for the answer, but the correct answer, I believe, should be B. So let's go look at that. Okay, go here, put in, I'm going to clear that. Alpha y equals enter. We're going to put in absolute value second catalog, enter. We'll put in here 2x plus 2. And then in the denominator, we're going to put x plus 1. What is that going to look like? I'm going to go to zoom 6. Jump discontinuity. The function is going along, just flat here, and then all of a sudden jumps up. Jump discontinuity. Answer choice D. Next, 13. Two functions fx and g of x are inverse of each other. What is g of x of fx equals x cubed minus 4? I'm going to do this analytically. We're going to do our 4-step process, change fx to y. We have y equals x cubed minus 4. And we're going to switch x and y, so we'll put down x equals y cubed minus 4. Add 4 to both sides of this equation. We get y cubed equals x plus 4. And then we take the cube root of both sides of the equation, we get y is equal to cube root of x plus 4. And the x plus 4 will be within the radical entirely. So for this, D will be our correct answer. 14, a polynomial function of degree 5 has one real non-repeating zero. How many non-real imaginary zeros does this function have? Well, this comes back to something we went over recently called the fundamental theorem of algebra, which is the degree of a polynomial function is equal to the leading exponent of the leading term of a polynomial function. So if we had, for example, y equals x to the 5th power, we would have to cross the x-axis at least once to start low and end high. But our so our total number of zeros for this is going to be 5. And if we subtract out our one non-repeating zero, how many do we have left? 4. So we have to have 4 imaginary zeros to make this a true statement. Okay, so we have 4 imaginary zeros. Next, 15. Which of the following statements about inverse functions is not true? The functions f of x equals e dx and g of x equals ln x are inverse of each other. That is true, so that's not right. And we could graph those in our calculator. We can put in ln x and we can put in e to the power of x. So we press there we go, second ln e to the x. We should get inverse functions of each other. See that? We're translating. I mean, we're reflecting about the line y equals x. Okay? So A is not correct. Any function that passes the horizontal line test has an inverse function, which is not true. Well, that is the horizontal line test will tell if a function has a inversely as a function. It is true. See, two functions that are inverse of each other reflect about the line y equals x. Yeah, we just saw it right here, right? An example of it here. So D, the composition of two functions that are inverse of each other is function f x equals 1 over x. No, it's not that. It's instead y equals x. And if you look at it, C and D are opposites of each other. So logically, one of them, they both can't be right. And so probably one of them is going to be right and the other one wrong. So that's number 15. Next, 16. If f of x equals x cubed minus 1 and g of x equals x minus 2, what is g of f of x? Well, first thing we have g of f, and so f is closer to 3. So the first thing we're going to do is find f of 3. And to find that, we're going to put 3 cubed minus 1, which is going to be 27 minus 1, which equals 26. And then we're going to find g of that. G of 26, I'm going to put the arrow here, g of 26 is going to be equal to 26 minus 2, which equals 24. And that's going to be, so we conclude that g of f of 3 is equal to 24. So B is our correct answer. Now, the last ones we're going to do, these last 4. What is the degree of the polynomial function below? Mark your answer in the grid provided. What we look for is the term that has the highest exponent value. And so it's going to be this one here, negative 6x cubed. And so for this, our degree is going to be equal to that power. So degree is going to be equal to 3. So if we just go here and put 3, and in the grid system we can put 3 anywhere in any of these spaces, and we don't have to put the plus sign in because the algorithm assumes plus even if you don't mark plus. It's really the minus you have to worry about. So marking the plus here is not absolutely essential. All right. 18 for the function g of x equals x cubed minus 5x squared plus 2x plus 8. What is the value of one of its real zeros? And I did instruct the class that there's the possibility of more than one correct answer on this one. Well, what I'm going to do is go and enter that function, which is going to be x cubed, and it's going to be minus 5x squared plus 2x plus 8. If we're looking for places that the graph function touches or crosses the x-axis, and I am not seeing that exactly. X cubed minus 5x squared minus 2x or plus 2x. I'm thinking, well, that looks wrong. Plus 2x plus 8. That looks better now. Now it's graph. So we have zeros. It looks like at -1, x equals -1, x equals 2, x equals 4. And we can go to table view. -1 we have 0, and at 2 and at 4. So those are zeros. So we have x is equal to -1, 2, 4. So what we'd have to do is pick out one of these numbers and put it in and get credit for that. If we pick -1, we got to put -1. Make sure we bubble in that negative sign. And if you were lazier, you would have picked 2 or 4 and not have to bubble in a negative value. Again, one of 3 possibilities, any one of which would be a correct answer for 18. 19, the elevation in feet of soccer ball kicked in the air is given by this function f t equals 40t minus 60t squared of t. Number of seconds after the ball is kicked in the air's foot was the maximum elevation of the ball. Mark your answer in the grid provided. For some reason on this one, I got people who just didn't round right to get a correct answer. So if we put 40t, in this instance, we're going to put 40x minus 16t, which I put down as x squared, and we graph that function, we get this looking thing. I'm going to tighten up to get a better view. Looks like we're in this quadrant 1. So I'm going to go to Window, start at 0, go to x equals 4, x scale 1, that's fine. Y minimum, we could leave that at 10, or we can make it 0. And then for y maximum, we can go up to 30. Now that shows you I probably know something about this function. There it is. We can do different things here. One way you could do this is you could trace. And when you trace this, you're going to get the very top value. If you go to very top value, you see what y is getting close to. That's going to be our correct answer. Okay, we're very close to top, almost 25. And to get a more exact answer, if you go to second trace maximum, it says left bound, go to the left of the maximum, press enter. It says right bound, go to the right of the maximum, press enter a third time. We get a maximum value of 25. So in a coordinate pair notation, it would be, the time would be 1.25 seconds, but 25 feet of elevation reached. And we're looking for the maximum elevation, which is going to be this second number here. So we can put in here 25. I have people putting in here 24. I don't know how. They must not have looked at it closely enough. Something happened there. And the last one we're going to look at is number 20. The function f of x equals quantity x plus 3 over x times quantity x plus 3. And so in this, we have x plus 3 over x times quantity x plus 3. So what we're going to have, if we graph this, we're going to have a non-removable discontinuity at x equals 0, but then we're going to have a removable discontinuity where x plus 3 is equal to 0. And solving for x, we have x is equal to negative 3. So that is going to be our correct answer. It's going to be non-removable, and this will be removable. So we'll put negative 3, negative sign. And the last thing I'm going to do, and that's our last problem, is graph this to show you what that looks like. So we go to the calculator. And that's one of these that if you didn't get this right, your analysis wasn't good, and you didn't maybe take the trouble to graph the thing. So we go ahead and put x plus 3 in the numerator, and in the denominator we put x times quantity x plus 3, close parentheses, and we get a standard window zoom 6. Okay, we have a vertical asymptote at x equals 0. And I'm going to go ahead and get rid of those points we plotted. There we go. But we have a point discontinuity where x equals negative 3. With the negative 3 we have error. So that is our correct answer. Well, that's it. Good luck, and as always, thanks for viewing.